In this video, we'll be discussing the principle of moments, and we'll be using this principle of moments to solve a particular problem in physics. But before we go into the problem, what exactly is the principle of moments, or what does it state? The principle of moments states that the sum of the total moments about any point equals zero. That is, the sum of the clockwise moments or moments at any point equals the sum of anti-clockwise moments or moments about that point. Okay, so basically, this is what the principle of moments says. Okay, it says that the sum of the moment about any particular point is equal to zero, and of course, that implies that the sum of the clockwise moments about a particular point would be equal to the sum of the anti-clockwise moment or moments about that point. Okay, now, before we continue, what exactly do we mean by moment? So, when we use the word moment, what does moment mean? Okay, so what does moment mean? All right, moment is simply the product of force and perpendicular distance. Okay, so when we say moment, we simply mean force times perpendicular distance. That means the product of a particular force and a distance such that the force should be acting at right angle or at 90 degrees to the distance. So if I have a particular distance such as this one here, now, and I have a force acting this way here, whether upwards or downward this way here. Okay, so let's say I have a force F here, and let's say distance from this point here where F acts, let's call this A, and let's call this B. All right, so we can get a moment from this to this. So the moment here, the moment for this diagram will be equal to the force F times the distance AB. Now, distance AB, because the force, as you can see, is at right angle to the distance AB. This is what moment means, okay? Force times perpendicular distance. All right, so having known this, let's now look at another thing before we solve that question there. So to proceed, let's talk about the concept of clockwise and anti-clockwise movement, okay? And to explain this, I'll simply use a clock to explain this, okay? Or a wall clock to explain this. Now let's assume this is a wall clock where here you have 12, okay? Here you have 3, here you have 6, and here you have 9, okay? And of course, we know that the hand of the wall clock moves this way. Okay, so if I have, let's say, this one here, okay, and then this one here, we know that the hand of the wall clock moves this way. So it moves, this is the direction, moves this way, and then goes this way. So it's from 12 to 3, 3 to 6, 6 to 9, 9 to 12, and then 12 to 3, just like this. Okay, in essence, it means that the hands of the clock moves in this kind of direction. This direction you have here is what is called the clockwise. This is a clockwise direction or a clockwise movement. Now, when you have a direction in the opposite of this, which means you're now going this way here, what you have here is a direction that goes in the opposite direction of the clock, and that's called the anti-clockwise. That's called the anti-clockwise moment. So that's different between a clockwise and anti-clockwise moment. Okay, so if the moment goes in the same direction as the hands of the clock, it's called a clockwise moment. If the moment goes in the opposite direction of the hands of the clock, it is called an anti-clockwise moment. All right, so having known this, let's use this concept to solve a problem in physics. Okay, now back to this question here. The question here says, for what value of W will the system be in equilibrium? Right? For the system to be in equilibrium here, would use the principle of moments. Why are we using the principle of moments? Because we can say that this weight or these forces are at right angles to the distance. This is at right angle, that's for W. This is at right angle, that's for 15 Newton. This at right angle, that's for 12 Newton. So they are all perpendicular to the distance or at right angle or having an angle of 90 degrees with the distance. All right, so hence we can use moments or the concept of moments or perhaps the principle of moments to solve this question. Now, how do we solve this exactly? For each of them, your first task is to always find the point to take moment about. That's always your first task, okay? Find the point to take moment about. Now, for this diagram here, remember we asked to find the value of this one here, W, for this system to be in equilibrium, all right? And for the equilibrium, we said the sum of the clockwise moments should be equal to the sum of the anti-clockwise moments. For this question here, we'll choose a neutral point, perhaps this point here. Let's call this one here, right? Let's call this P. So we'll take point P as a neutral point. So hence our next task will now be to take moment about P. All right, so at this point here, we'll simply take moments about P. So we'll say taking moments about P. All right. So how do we do this? From the principle of moments, we have that the sum of clockwise moments will be equal to the sum of anti-clockwise. This is like clock, please. Clockwise moments. All right. So with this, we'd have that the sum of the moments, that's clockwise moments, is equal to sum of the anti-clockwise moments. All right. So back to this. Our task would be to get which of them is the clockwise moment and which of them is the anti-clockwise moment. Now, to get that, you just simply need to trace each of the directions. Okay. For the forces, trace each of the forces towards P. Let's start with W there. Now you have your weight W here, or force W here. If I trace W towards P, this W is coming downwards, so it becomes trace this man downwards towards P. So I have this direction. All right, so that's downwards towards P. Now look at this direction. So look at this direction here. If you have this kind of direction here, is this clockwise or anti-clockwise? Now, to be sure, you can trace this in full. So it goes like this. All right, so from this you can see that this is actually anti-clockwise. All right, this is against the hands of the clock. So this is an anti-clockwise moment. So we'll call this A. Let me call this A. A is anti-clockwise. Let's go to 15 Newton, which is this one here. Let's trace 15 Newton. 15 Newton is coming downwards, so I'll trace this downwards then towards P. All right, so see the movement. All right, downwards and towards P. So this motion you have here, is this clockwise or anti-clockwise? Now, to be sure, you can just trace this in full. This becomes this way, and then it goes like this. And of course, this is the way the hands of the clock moves. It moves like this. So hence, this is actually a clockwise movement. So I'll call this C, clockwise movement. Let's come to the next one there, which is this here, 12 Newton. Now for 12 Newton, this force is coming downwards. Trace it downwards towards P. This will be downwards like this towards P. What you have here, is this a clockwise or anti-clockwise moment? Well, that will be simple. All you have to do is just, you can trace it in full if you want to. So it's like this, and then it goes this way. And of course, this is the same direction as the hands of a clock. So this becomes a clockwise moment. So it means 15 Newton and 12 Newton are the clockwise moments, or would give the clockwise movements, while W is the anti-clockwise movements. Now, having figured this out now, let's now get the moments. If you take 15 here, remember that we said moment is equal to force times perpendicular distance. All we have to do is take 15 there. All right, for clockwise moment, we take 15 here. So it becomes 15 times the distance between 15 Newton and P. We can see that from our diagram there, the distance between 15 Newton and P is simply 6 meters, as we have here. So it becomes 15 times 6. That's all. All right. So it becomes 15 times 6 as your clockwise moments for the 15 Newton force. So I'm having this as, for clockwise moment, I have 15 times 6. I'm done with this. Let's look at the next one there, which is the 12 Newton. Okay. For the 12 Newton, you have that this was actually clockwise. So we would add it to the clockwise section. So it becomes plus 12 Newton into, let's get the distance for the 12 Newton force. From your diagram here, the 12 Newton starts from this point here and goes all the way to this point here, and we would combine the distance, so it becomes 6 this here plus 5. And if you combine 6 plus 5, you have 11 meters. Okay, so the distance between the 12 Newton, from the distance from the 12 Newton force to P in total is 11 meters. So this becomes 12 times 11. All right, so these are all my clockwise moments. This will be equal to, let's now get the anti-clockwise moments. So for anti-clockwise, you have W as your force. So that's equal to W as a force. What's the distance from W to P? From this diagram here, we can see that from W to P, that's from this point to this point here, in the question, we have about 10 meters. So we have 10 meters as your distance. So this becomes 10 meters. All right, so we have this. From the principle of moment, the clockwise moment, which is or which includes all of this, it's equal to the anti-clockwise moment, which is this one here. All right, let's solve this. So first things first, we have 15 times 6. Just punch this directly and see what we get. All right, so the first one that we have is 15 times 6, and that gives you about 90. So this becomes 90 plus, next thing I have there is 12 times 11, that's 132. So I have 90 times 90 plus 132 is equal to W times 10 gives you 10W. So we have this. All right, let's sum this up now. So if we have 90 plus 132, what we have as an answer is 222. So this will give you 222 is equal to 10W. Of course, to get the value of W, I'll have to divide here by 10, divide here by 10, and this cancels this. 222 divided by 10 gives you 22.2 as being equal to W. Don't forget that if you look at this concept here, you see that W was representing a force. 15 was in Newton, 12 was in Newton. That means W will also be in Newton. So W would be equal to 22.2 Newton. So hence, using the principle of moment, we have that the value of W is 22.2 Newton. All right, so this is how you solve this question. Now I want to ask a question. Let's say I add a particular force here. Let's say add a particular force here. Excuse me. Okay, before then, let me take off this thing here. So I'll take this off. So take off this one too. All right. So let's say I add a particular force somewhere around these points here. All right. So I call this force here. Let's call it force X. Should we use X? Let's use force X here. All right. Now this is X, and don't forget that this is position P here. All right, this is position P, this point here. Now take the moment of X against P or towards P here. Do you think it will be clockwise, right? Or do you think it will be anti-clockwise? Take a moment to look at this. Of course, what you have to do here is simply trace X, right? Trace X towards P, and then you see if it will give you a clockwise or anti-clockwise moment. Leave your answer in the comment section. All right, if I take the moment of X against towards P, all right, will it be a clockwise or anti-clockwise moment? Leave your answer in the comment section. All right. Okay, then, if you enjoyed this video, as usual, please do well to hit the like button. Right, so like this video, leave a comment. In the comments, tell us if the moment of X against P is clockwise or anti-clockwise, and I'll give you a reply to tell if you're correct or not. Don't forget to also subscribe to this channel. If it's your first time here, do well to subscribe to this channel and hit the bell icon so that you get notified whenever we upload new content. Then, of course, finally, don't forget to share this video to your friends so that they can also learn. Also, do well to visit my website. Okay, visit my website www.jonahemmanuel. So www.jonahemmanuel.com. All right, so you can see You can go to the book section to see the available books, and also you can go to the courses section to see the available courses. But note that you have to create an account with the website before you can get access to either the books or the courses. All right. Thank you for your continuous support and see you in our next class.